10.2 circles. What we're going to cover is what's called the conic sections. And circles is the first of the conic sections. How do we create conic sections? Well, we take a cone. Now, it's not the same type of cone you're probably thinking of. In math, a cone actually has a top and a bottom. So you probably think of a cone like a waffle cone. Stuck two of those together, that would be a mathematical cone. And if we cut this cone in different ways, we can make different shapes. Okay, and the one way of doing that is to cut parallel to a base. Now, if we cut that cone parallel to a base, what we'll cause is we'll cause a circle. Okay, so cutting a cone in certain ways will cause different types of conic sections. This is a circle. If we cut that cone in a different way, let's say a vertical way, then what we would cause is, I'll just draw this off to the side, it's hard to show, we would have this shape. That's called a hyperbola. So if we cut perfectly parallel to the base, we get a circle. We cut vertically perpendicular to the base, we get a hyperbola. If we cut at an angle, what we'll end up with is an ellipse. Something, some say egg-shaped. It's not really an egg shape. It's perfectly symmetrical. Okay, eggs usually are not, but that would be an ellipse. So we have circle, hyperbola, or some say hyperbola, hyperbola, ellipse. Which way do you cut the ellipse? The green. Diagonal through one half of the cone.
So, parallel base gives you a circle.
Yep.
Perpendicular is hyperbola.
Perpendicular would be hyperbola. Diagonally through the cone will give you the ellipse. And the last one is a parabola. Okay, let me show you how the parabola shows up. If we cut diagonally through the open part of the cone, through the base, okay, or through the top, you will get a parabola. So I'm going to draw it. So if we follow this, it would look like this. It's going down. Now it looks a lot like a hyperbola, but it's not. There is a difference. Okay, and if we talk eventually, if we mention the word eccentricity, we can show you the difference between a parabola and a hyperbola because they do look very similar. Ellipse and circle are pretty easy to distinguish. But those are the four conic sections that we're going to look at. And today we're going to study circles. Okay? Yes, question? This cut right here is a black. See how I drew the cut in the same color as the shape? Diagonal, that goes through the base or through the top. Yeah, it must go through the opening. See, if we draw diagonally, the green line is the ellipse. Diagonally, but not through the opening, not through the base or the top, you get an ellipse, right? But this one actually goes through. All right. So let's talk about circles. Formula for a circle. This is the standard form. X minus h quantity squared plus y minus k quantity squared equals r squared. where HK is the center and R is the radius of the circle. So the H and the K tells us the center, the R tells us the radius. All right, so let's put it to use. Example. Right, the standard form of the circle that is tangent to the x-axis and has its center at 3, -2. What does tangent mean? Touches whatever it's tangent to, right? At a specific one specific point, right? So 3, -2 is the center. It's tangent to the x-axis. Where will it touch? At what point? At 3, 0. Tangent to the x-axis. It's touching at a single point. That tells us something. Okay, this is our center at 3, -2. We're touching at 3, 0. What's this distance? 1, 2, which happens to be what? The radius R. Center to a point on the outside of the circle is the radius. So R is 2. The center, we'll see, is 3, -2. Let's go ahead and finish drawing this so we have an idea of what it looks like. If I go 2 up, I'll have to go 2 down, 2 left, and 2 to the right to get a decent looking circle. And if I had a much better graph or a much better grid here, it would look more like a circle. That's actually not too bad. It's better than I thought it would look. And we could name all the points on the outside of the circle if we needed to. Okay, but just a center and one of the outside points would be perfectly fine. So we know that. Our equation is x minus h squared plus y minus k squared equals r squared. What's my h? Let's see here. HK is the center. So h would be the first number, in this case 3. Y, what am I going to put there? Plus 2. Yes, there is a negative. It's -2. 2 negatives make a positive. Radius is 2. 2 squared is 4. That is the standard form of that circle. what would you solve for? That's it. When you have an equation, usually you have two variables involved, right? Flat, two-dimensional plane, right? Not a three-dimensional area. Okay. Flat, two-dimensional plane. You have an x and you have your y. Do we have an x and do we have a y? Yes. So we have an equation. If we just had an x, yeah, you could solve for that. If you just had a y, we can solve for that. We could be solving an equation. This is just the equation for that graph. This represents all points on that circle. Nothing to solve yet. All right. Now there's another form called the general form. Okay, the general form is x squared plus y squared plus dx plus dy plus f equals 0. And we could have used a, b, and c. The variables really don't matter. D, e, and f. Oops. Or just constants. Could be any number. It's going to change depending on the equation. So that's general form. General form can be put into standard form, and standard form can be multiplied out to put it into general form. Okay? So we're going to do that. Right. 2x squared plus 2y squared minus 4x plus 12y minus 18 equals 0 in standard form. So we are given the general form of a circle, or at least as close as we can get. At this point in time, it's pretty close. What's distinct about the general form is an x and y are usually plain old x and y's. There's no numbers on that. So we could divide by what here to start? 2. Let's do that. Let's get started by doing that. Divide everything by 2. We get x squared plus y squared minus 2x plus 6y minus 9 equals 0. Now it's in general form. We want it to be standard form. You scroll back up and look at standard form. We have a quantity squared with an x in it. We have a quantity squared with a y in it. How can I make a quantity squared? What? Factor? Kind of. Let's rearrange. We have all the x's. We have one x here. We have one x. We have one y here, right? So watch this. Let's group all the x's together. So I have x squared minus 2x. Put the y's together. We have plus y squared plus 6y. I'm going to get that number away. So I added the 9 over. Here's all my x's. Here's all my y's. want to turn this, all the x's, into a quantity of x plus or minus something. And I want to change this into a quantity of y plus or minus something. That still wouldn't give me a single x. All right? Because I'd have an x outside, I have an x on the inside. If I divide by x, I have to divide every single term by x. I like all your ideas. Okay? But you're forgetting one thing. One very fundamental thing. No, not log. Now you're getting crazy. Completing the square. Remember completing the square? Let's try it. Well, I'll remind you that. In order to complete the square on the x's, I have to add a quantity squared. I want it to be a perfect square. That's why it's called completing the square. I'm completing a perfect square. And if I have a perfect square, it'll factor to a quantity times itself, which I can put together and give me a quantity squared. Okay, that's completing the square. We did this earlier in the year. Let's do the same thing for the y's. Y squared plus 6y plus some quantity squared. On the right side, if I do something on the left, I have to do the same thing on the right. So let me put this parenthesis in blue. So I'm going to add that quantity squared. Let me put this parenthesis in red. I'm going to add that quantity squared. Okay? So you see where those are coming from. If I do something on the left, I have to do the same thing on the right. All right. Does anybody remember how to complete the square? Yep, half of what? Half of the number in front of the x. So specifically, -1, right? Okay, we want to keep the sign. So we're going to put a -1 here. We'll put a -1 here. That's half the number in front of x. So what's half the front of number in front of y? 3. 3. 3. Okay. Now, if you don't want to multiply this out and factor, shortcut is you write down the variable x, you write down whatever you just put into the quantity squared, and square the entire quantity. I just skipped 2 steps. Works like that every single time. That's how we complete the square. Okay? If we multiply this out, we get a 1. We could then factor it. We get x minus 1 twice. We could put it back together. Works that way every time. We do the same thing with y. Put y, whatever's in the parenthesis, we just squared. So plus 3, square your quantity. And on the right, we actually have to get a number. So we have 9 plus 1 plus 9. How much is that? 19. Check this out. Is that standard form? Yes? No? What's my center? Be careful. 1, -3. Remember, it's x minus h. This is my h. Y minus k. So it's always the opposite, right? The opposite sign. So my center is 1, -3. What's my radius? R squared is 19, so R would be square root of 19. Very good. And we could graph that, right? Plot the center, and then we go up, down, left, and right, square root of 19. We have to get a decimal approximation on that, right? I think you could do that, though, if I asked you to graph a circle. Give me questions. That's the toughest thing you're going to do right there, is go from general to the standard. Standard back up, you're just going to FOIL this out. So it's not a big deal. That's not that big of an issue. All right. No questions? Let's try one more. I think one more. guys remember anything about matrices? Very little. That's discouraging. All right, let's try this. Let's go general. Write the general form of the circle that passes through -5, 3, -2, 2, and -1, -5. You may have done this in geometry. I'm not sure. I ask about matrices because the simplest way to do this is with matrices. We have 3 points. Do we know anything about the center? No. All we know is general form. General form is x squared plus y squared plus dx plus dy plus f equals 0, right? Is that correct? All right. Since I know nothing about the center, I know nothing about the radius, all I have is x and y's, I'm going to plug some in. I'm going to plug in 5, 3 into this form. Now what does 5 and 3 represent? X and y. So I'm going to put in 5 squared plus 3 squared plus d times 5 plus d times 3 plus f equals 0. Or 25 plus 9 plus 5d plus 3e plus f equals 0. Or 5d plus 3e plus f equals, what's 25 and 9? Move it over. -34. Okay, you see how I got that equation? Okay, this is not the answer. This is the first equation. You follow how I did that? I'm going to do that again for the other 2 points. Okay? Exact same thing. This is a bit tedious, but this is how you would do that if you have 3 random points on a circle. It's not difficult, it just takes some time. So what's the second point? -2, 2. Okay, so we have -2 squared plus 2 squared plus, I'm just going to, actually let's just write, no, e times -2 plus e times 2 plus f equals 0. 4 plus 4 plus, about minus 2d plus 2e plus f equals 0. No, anything squared is positive. So it'll be positive 4. So we have -2d plus 2e plus f equal to -8. Right? Yes? Do you get what I'm doing so far? Last one. And the last point is -2 negative 1, negative 5. So negative 1 squared plus negative 5 squared plus e times negative 1 plus e times negative 5 plus f equals 0. Right? 1 plus 25 minus d minus 5e plus f equals 0. So in other words, negative d minus 5d plus f equals, looks like negative 26. Does everybody follow what we've done so far? We've taken the general form and simply plugged in x and y. Yes? I'm going to rewrite the three systems. What was the first equation that I circled?
5d plus 3d plus f equals
The second one?
negative 2d plus 2d plus f equals infinity.
I can see that one. I have three equations and I have three unknowns. Okay? Now, we have two choices to solving this. We've done these this year. We could solve the system by elimination. I wouldn't do substitution. Okay, I would solve by elimination, or we can use augmented matrices and let the calculator do the work. As I mentioned earlier, before we even started the problem, remember anything about matrices. Because I think augmented matrices, let the calculator do the work, is a little bit simpler than doing this by hand. But you could do it by hand. We would eliminate a letter from the first two, eliminate a letter from the second two. Those two equations, we'd eliminate another letter, leaving us with a single letter to solve. We've done this. You go back and look in your notes. We've done matrices. We've done that this year. We did it with systems of equations. We did 2 and 3. We also did them with the calculator using matrices. So, get your graphing calculator out. All right, I have the 84 plus silver edition. I'm going to hit the matrix button. The matrix button is second, x to the negative 1. Fourth button down the left side. Second, x to the matrix button. And we have some matrices. Names, math, and edit. We're going to go over and we're going to edit matrix A. So go over to edit by pushing to the right twice, and then push enter. And it asks us, what size of matrices would you like? Do you remember what size this would be? 3 by 4 or 4 by 3? Oh, let's find out. 3 by 4. I think 3 by 4 works. So 3 is the vertical, 4 is the horizontal. So what's our numbers? We're simply going to put in the coefficients. 5, 3, 1, and negative 34. Negative 2, 2, 1, and negative 8. Negative 1, negative 5, 1, and negative 26. Well, once I have the matrix in, I'm going to go back to the home screen by quitting. Second mode is the quit. I'm then going to go back to matrix. And I'm going to push 1 to the right. And I'm going to, underneath the math, go all the way down to RREF. Does anybody remember what that means? Row reduced echelon form. Row reduced echelon form. Some say reduced row echelon form. I don't think it really matters. Math, you're going to matrix, then push to the right one. Under the math, you go down to letter B, R, R, E, F. Now, what row reduced echelon form does is that it transforms our matrix that is currently 5, 3, 1, negative 34. I'm going to put a little dotted line here because that's an augmented. Negative 2, 2, 1, negative 8, and negative 1, negative 5, 1, negative 26. What it will do, the row reduced echelon form should give us this setup. And then 3 numbers on the right. If 1 represents this first space, what would it represent here in our equation? Just D. There's no E, there's no F, and 1 times D is D, so this first will tell us what D is equal to. What's the second one going to be? What E is equal to. And the last one, what F is equal to. If we know what D, E, and F are equal to, we can plug it back into our general form, and we will know what our equation is. And then if you feel like it, because you're bored, you can go ahead and take the general form, put it in standard form. Right? You're not looking too bored, so we won't do that. Let's just get the general form. So I picked R, R, E, F. I then go back to matrix, and I'm going to pick my matrix A. So I'm going to do a row reduced echelon form on A, and there it is. We're getting a negative 4, a 2, and a negative 20. So D is negative 4, E is 2, F is negative 20. So x squared plus y squared plus dx plus ey plus f equals 0 turns into x squared plus y squared minus 4d, minus 4x plus 2y minus 20 equals 0. We now have the general form of the circle. The three completely random points we know are on this circle. Do we still know the center? Do we have any idea what the center is at this point in time? No, not really. What would we have to do to figure out what the center is? Put it in standard form. We want to know the radius. Put it in standard form. Okay? Which causes us to do what? We're going to have to complete the square, right? We've got a couple minutes. You want to do that real quick? We're going to call it a day. I'll leave it up to you. You don't want to practice completing the square anymore? Always, definitely. All right, let's do it. This is not part of the question. We're going to do it anyway. I'm going to group the x's together. We're going to try to do this a little bit more efficiently. I got an x, I got an x, I got a quantity squared, right? I got my y squared, I have my y, and I have a quantity squared. I move the 20 over, and I'm going to add 2 quantity squares. A little bit more efficiently. Do several steps at one time. What number goes in the first quantity squared? Beautiful, negative 2. So I got a negative 2. What goes in the second one? 1. What goes over here? 1. Great. So I got x minus 2 squared. I got y plus 1 squared. And on the right, I have 20 plus 4 plus 1. Looks like 25. I have standard form. That wasn't too bad, was it? I have standard form, though, right? What's the center? Careful. X, y. 2, negative 1. My radius is 5. Beautiful. We didn't even need a minute for that. That's not too bad, is it? like I said, most of the work was in finding it. But 3 completely random points. Make a circle. That's pretty powerful stuff there. All right, if there's no questions, and that's it for today.